Welcome to clickmybrother.com. Scalable face image retrieval using attribute enhancer code work. Retrieval in large scale system is to be very difficult. We have to detect the human face by some pre-processing techniques. For efficiency in large scale system, we have to use two orthogonal methods called feature extracted, sparse coding, and classification based inverted indexing in both online and offline stages. We have to effective face retrieval with vital essential factors in different properties in faces. Nowadays, the popularity of face networks like Facebook, Twitter are mostly used by the people. Many of them use human face images to their profile, and also we can maintain the large scale database for image storage to avoid the largest database used to algorithms like attribute enhancers, sparse code words, and attribute embedded and inverted indexing and used online and offline storage respectively. In large image database, we have problem recording the image retrieval. By using this algorithm, we can efficiently retrieve the images from the large image database. It will give the 80% perfect matches. Face image retrieval from large scale database is a challenging problem and is beneficial to many real world applications. In this paper, I propose to develop a method where I exploit the special properties of faces like local features based on Hamming distance to encode discriminative local and global feature for each face in order to retrieve the required image from large scale database. This is the flowchart of our process. This flowchart contains several steps of process the face image retrieval, such as the query image pre-processing, landmark detection as a patches detection, and feature extraction, and also the final step is the classification using the patches in the input image. We have to discuss the steps of a flowchart one by one. The first step is the query image. Query image is to get the input faces images. In our process takes input different actions and expressions based color and gender and etc. Those input images this helps to detect the face and extract the features to and find the output face for attribute in our following steps. The next step of our process, the pre-processing. The pre-processing, like the input phase, is to get to the improve the quality of input image. The in pre-processing steps have to the converted the grayscale image and filter the image to remove the noise to smoothing the input image. The next step is the face reduction. In this face reduction, to get the input face to detect the default detector of basic MATLAB function. In this process, we have to displace the contour at the boundaries of the face of the image. This is representation for fixes the batches at the face in the input. The next step is the landmark detection. The landmark detection is an important part in our flowchart to detect the patches of our input face. In this patches, we have to detect the normal human parts of a face, like eye, mouth, and nose ears. The spots is detected from this landmark detection. The feature extracted from this batches, and it is a very help to classify the input values. This is a very important process to find the next step is like feature extraction. This is very important process for find relevant images and finding attributes of input image. We have to separate the batches of eye and mouth regions of input image. Using those regions, will take values as features for the extraction. Put those values apply on the LBB algorithm and create the feature values for the classification. In LBB is LBB pattern generate identify the pixel information of image. Local variant patterns created by intensity values of images. The local binary pattern extract the binary value based on threshold of nearest pixels and convert to the decimal. It give the information about image. The final step is of our flowchart is the final step of our flowchart is the classification. The classification based indexing. The classification is used to classify the features to identify the relevant images during the identification using SPM classification. In our process, we have to done the classification extracted features from the input images. The steps is using to extract the features from the given images and then perform the classify to all images each by each in the database. This technique is very useful to select relevant persons from the existing dataset in the process. This is the final process for select the perfect matched person and their attribute from a whole dataset in a project. This is the output of our process scalable face image retrieval. In our proposed we have to retrieving the large scale content based face images or by face landmark reduction by AI points in this process to efficient from using some orthogonal methods accurately retrieve the large scale content based images easily. To orthogonal methods work out well in retrieving the similar faces from the large scale database. In the existing system appearance are used, but we propose high level human attributes which are effectively in case of image retrieval from the large database. Conventional face matching systems generate only numeric matching scores as similarity between face images, but in the proposed method combines two methods to utilize automatically detected human attributes to significantly improve the content based face image retrieval. Thank you.